Yeah, so welcome to the latest edition of GEOSeries from European Space Imaging. My name is Matthew Shelnut. I'm the Director of Digital Marketing here at EOSI. Today, I'm joined by our speakers, Valerio Gulli, George Ellis, and Daniela Valentino. They'll introduce themselves shortly. And we will discuss today the choice between aerial imagery and 15 centimeter satellite imagery, in particular for city and regional mapping, but also generally for a range of applications. So we've planned about an hour for this webinar today, so hopefully we stay on schedule and don't run over. But first, if we could discuss a few quick housekeeping topics. So we'll have a live Q&A portion at the end of the webinar. If you have any questions, please put them in the Q&A section to the right of your screen. We may not have time to answer all of the questions live, so some of them might be answered via a written response from our team here on the back end. Next topic, let's see, there was a survey sent to participants a few days ago. We plan to review some of the responses during the presentation today, but we also have a new question to ask live during the event. So you can find that in the polls section to the right of your screen. We'd be very interested to see what some of those responses are and maybe discuss them at the end. And last is sort of a tip. If at any point you want your screen to be bigger to see the presentation a little better, you can exit out of the chat window and then click the full screen button. So both of those will expand the screen a little bit, the second one expanding it the most. So I believe that is everything. Hopefully this goes well. No technical errors. Everyone's audio is working, video working, internet connections going well. So without any further delay, I will pass this to Valerio to get things started.
Hi, Matthew. Thanks. Thank you all also for joining us today. I'm very happy to be here. So my name is Valerio. I'm the Senior Business Developer Manager at European Space Imaging, and very happy to be working together for the preparation of this webinar together with Daniela and George and sharing the microphone. So Daniela, if you want to have a brief introduction as well, go ahead.
Hi, good day, everyone. I'm Daniela Valentino from Planetek Italia. I'm a product specialist in the market of satellite data.
Thanks, Daniela. George, if you want to have also a brief introduction.
Sure, thanks, Valerio. Yes, my name is George Ellis. I'm the Vice President of Operations at European Space Imaging. I'm with the company since about 20 years, and I'm very honored that I have the opportunity to show you a little bit of what we are doing, what I'm doing since 20 years for the company. Thank you.
Yeah, thanks, George. So I will be sharing the slides, just a quick check that everything is okay. Yeah. Okay, I think you can see the slide right now. Just write me in case if not. So just going through the webinar agenda. As been already shared by Matthew and also George, it's a high technical session. So we've been putting together a lot of feedback from the aerial point of view and from the satellite. We have to simplify some of the topics due to the complexity of what has been sharing, but we've been working very nicely together. So we will go through quickly through the agenda. I will start to talk about scalability for countrywide and nationwide mapping projects. Then there will be a few feedback about time and resources. George will present and share a little bit more with you about our intelligence collection planning framework. And then Daniela will lead a natural real use case from a municipality in Milan, which is using European Space Imaging data, high resolution data for the projects. And then we will have a brief overview about products, resolution, accuracy. There will be also some inputs about geographic restriction. And as Matthew mentioned before, we will also have a Q&A. So I'm sure that you are very familiar if you're attending this webinar with this question: should we use VHR satellite imagery? Should we use aerial, or should we use a combination of both? This question was the trigger for starting to work on this series and the next webinar as well. For sure, if you've been a project manager, you've been facing this type of question, and it's very nice, thanks to the survey that we have been sharing to you. And I'm also very happy to get a very good response. So thank you all for joining and also for participating to the survey. This answer and feedback that we've been sharing and confirming what we have been thinking. So many of you are already using satellite aerial data together. A good amount of our clients are also directly using satellite imagery, and then there is a mixture of use cases. What is interesting from my side was also to see the actual resolution. So there is definitely a high demand for very high resolution imagery, going from 1 to 10 centimeter, which of course is addressed from aerial platform or UAV. And then 10, 15 centimeter, where we also have a product with the 15 centimeter HD, and 30 centimeter, 50 centimeter, which is also like from the satellite domain. Briefly about our company, European Space Imaging has been in the market for more than 20 years. Is a lighthouse for the geospatial business. In particular, has been the first company to bring to the market VHR imagery. We have our ground station, which is based on Munich. We work very close together with DLR, and in general, we process around 3,500, 4,500 VHR orders per year. We have more than 1,700 happy clients, I like to say, spanning across 59 countries from Europe, Middle East, and North Africa. I want to share, and perhaps you also receive our recent press release. So we made a significant investment in Europe with additional 4 million to upgrade our ground station, and we can now manage multiple near real-time orders in parallel. At the same time, we can so work for emergency response, security, or special projects, and we are undercutting the delivery time from 30 minutes down to 50 minutes, which is truly outstanding. So we are so setting new standard for the latency of Earth observation data, and we are very proud to bring this forward in Europe. Here is just a brief overview about the sensor technology and how this has been developing over the years, which is truly impressive. And without further ado, I would like to focus also a little bit on the sensor parts. So this is the current satellite that we can directly task from our ground station. This is the Maxar Worldview constellation. And once the Legion satellite will be operational, we will be able also to task the Legion. To give you a perspective of what is possible in terms of scalability and possibility to collect per day, for example, we can go with the Worldview 3 up to 680,000 square kilometer per day at 30 centimeter, which is truly impressive. And the topic of the webinar is, of course, our 15 centimeter imagery. And here is just to provide you a brief overview of what this product is about. So the actual native image is 30 centimeter collected with Worldview 3, for example. Then through the HD, which is a proprietary method developed by Maxar Technology, we are able to intelligently increase the pixel from 30 centimeters, so class image, we have an output of 15 centimeter HD. As you can see, it's coming very helpful for better visual clarity. This is an example, is Heathrow Airport. This image is 15 centimeter HD. As you can see, we can zoom in with an incredible level of detail. We have a very good visual understanding. We can define specific type of vehicles. The aircraft get much sharper, so all the details also in the marks in the roads are getting much clearer. To have a one-on-one comparison between the 30 centimeter and the 15 centimeter HD, so as you can see, you have the 15 centimeter on your right. Features are much better represented, and very often for analysts that this is enough to understand what sort of vehicle, for example, you have, or do also classification of military aircraft and so on. Of course, this product, as you will see in Daniela's presentation, interpretation, is also used for urban mapping application from city council, thanks to the high resolution. So you can also have a very good overview of what you have in the area. But you will see this in the use case. So an overview of the different type of and the flexible mission planning collection. Here is just like a very brief summary, which we put together to have just a quick overview for you. So what it's truly understanding is that in a single pass, so if you look, for example, for the long strip with 13.1 SWAT, we are able to collect by sweeping the sensor a strip that is going from London to Paris in less than 45 seconds, which is truly impressive if you think what you can do in 1 minute. So that is really something interesting to see. And at the same time, to start to have some perspective how this SWAT and capabilities are comparing with other platforms. So if you look at the WorldView 3 satellite, I was mentioning before that we have a SWAT of 13.1 kilometer at nadir. Of course, the SWAT of the aerial camera, and here we have used an approximation of a large format commercial aerial camera. It's going around 3 kilometer, and of course, for UAV, the SWAT is going to be even smaller. So to put everything into perspective, here you have a better overview of the SWAT width that you have from the satellite sensor and the aircraft and the UAV. The idea of the webinar was also to cross-checking from past projects and seeing also finding some correlation and providing also some internal feedback on the platforms. And in this case, we've been using a project that we did in the city of Berlin. The sensor is the WorldView 3. So the whole area, which has been captured with a single pass, 5 strips in less than a minute. So this shapefile that you see is around 1,850 square kilometer. The collection time, as mentioned, was less than a minute. And what is truly impressive is not the collection time that is happening basically in 60 seconds, but is also the delivery. So everything can be delivered in less than 2 hours for the 30 centimeter imagery. And the client within the same day is also receiving the HD product. That is an image, just an overview from Berlin. Having an approximative estimation, which have been working with the team, in case the same project was done with an aerial system. So again, an average large format aerial camera, we are in the range, so matching exactly the same area of interest in the range of 16 hours operation, so around 2-3 days flying, resulting in around 13,000, 15,000 images. And then there are different topics to be planned, for example, the logistics, if the airport is a little bit far from the production center, or if the imagery are uploaded, for example, overnight to the cloud. So maybe the data delivery will be within 1 week or 2 weeks, just as an estimation. So of course, there are some capabilities and pro and cons that you have with different platform, but the idea it's also for the scalability point of view with the WorldView constellation, and here we're considering the entire constellation, is scaling, for example, for the city of Berlin to the entire Germany. This is possible, so we will get around 360,000 square kilometer. The entire collection can be done around 63 weeks, resulting in 1,200 images. The idea overall of this webinar is providing some feedback and approximative estimation, not only on the mission planning point of view, but also on the data sides and processing. Of course, the platform are having a different type of workflows. So if you look on the satellite imagery, for a 15 centimeter product, we are in the range of 0.15, 0.16 gigabytes per square kilometer. So going back to the project that I was showing before, so the city of Berlin, we are around 298 gigabytes. At the same time, of course, considering also the high level of detail, the granularity that you have in a aerial image, the data size is also coming. So it's 1.5 gigabytes per square kilometer based on some estimation that we've been calculating. So resulting for the city of Berlin or around 1.52 terabytes of imagery. From the production and processing point of view, I mentioned about the near real-time capabilities that we offer already for special project or security, but of course from sensing, so from when the image is collected to when the actual clients get the image. We have use cases of 15 minutes, for example, for EMSA, but we're talking about within the day or few hours. So, and you will see also an example of RapidDAM, where you get actually the digital elevation model within the same day. So from collection to processing. This is something that we do together with GAF. At the same time, considering the same so considering an increased level of complexity for the aerial platform, we will have 2-3 days to cover the same AOI. Then the processing time, as we were mentioning before, is going to be maybe 1-2 weeks. But of course, it depends on the logistic of the company, how the data is uploaded to the cloud overnight, for example. But this is adding an additional level of complexity considering the amount of data and thousands of imagery. So usually for a quick response, the satellite is giving lighter data sets and with the possibility to be processed also within the same day. Few way of collection. So this is the classical aerial chessboard, which I'm sure you're very familiar. There are different type of collection sets, like can be the overlaps changing 80-60, for example, for city centers, but can be also 60-30 depending on the area and the products that the company has to provide. At the same time, from the satellite point of view, we can also capture up to 5 stereo combination on a single pass. And of course, by adding, like, let's say from 3 to 5, adding additional data is increasing the redundancy and is also improving the overall model accuracy. In these regards, I will show you a video that I was just mentioning. Okay, I have to stop sharing. So it will take a little while, but you will see actually a 3D model from satellite imagery. This is the city of Hamburg. And we work together with GAF, our partner. The product is called RapidDAM. The delivery is within the day. So European Space Imaging, the operation team is collecting the imagery, stereo collection, as I've been sharing just before. So the imagery are delivered to the client. At the same time, GAF team is processing the data, and this is the results. So of course, these models are quick, can be produced within a day. So you have different type of application from GeoInt, emergency response, simulation, urban planning, and comes in very handy considering a quick delivery and collection. So we will move now into the intelligent collection planning. So I will give the microphone to George. And George, feel free also to share the slides so we can go to this part of the webinar.
Thank you, Valerio. Thank you very much. So I'm going to share my slides. Playing a video? No. So hopefully you're seeing my presentation now. And
it's all good, George.
It's good? Okay. Okay, are we back again?
No, you have to reshare.
That's strange.
Yeah, maybe just try it again.
Yeah, I'll be there in a second. Window.
Yeah. Now you're set. Yes, we can see the slides.
Okay, perfect. Thank you. I knew there will be a hiccup, but okay, we get started. So thank you, Valerio, again.
Yeah.
All right. So Valerio already mentioned what we call intelligent collection planning, and I would like to introduce you to what we mean by that and how we apply this to usually larger scale projects. Okay. Intelligent collection planning can be quickly summarized that we apply expert human-assisted planning and tasking. We obviously have very sophisticated planning software for the satellites, and they present us with what we call suggestions. And then we have our experts going over those suggestions, and then they see if they can increase the collection area, if they can shoot around clouds. That sounds strange, but I will show you some examples in a minute. Then we can apply some smart tactics, how we can improve the image quality by doing smart recollections. And last not least, how we usually avoid sun glint. So I will go through all these points in the next few slides now. So how do we start with large-scale projects? It all begins with a feasibility study, right? So if you have a large project, then you have to split it in smaller, manageable parts. In this case here, down to the lower left, you'll see we had to collect all of Greece, and we split Greece into smaller segments. The next step would be that we applied satellite capacity to those segments. So we know that how often does a certain sensor fly over the target, how much can it collect per pass, and that will summarize how fast we could collect the area, disregarding any weather influence, because that's the next step. So first we get a number, say for all of Greece, it would take 3 weeks to collect, but then we have to look at the weather, and even in Greece and areas like Spain and Italy, there are some clouds occasionally. And that's the center slide you see here, the center chart. You see the different cloud cover percentages, statistically speaking, over Europe. So if you have a collection project over Spain or Greece, it's usually not so difficult. But if you have to collect something over, say, Scotland or the UK in general, you may have to try for a couple of days until you get a usable image, right? So once we apply all these satellite capacities and the statistical weather numbers, we run this through some kind of sophisticated mathematical forms. Then we come to a prediction, and that's the top chart you see here, the blue line, the blue dotted line, would be the prediction of the collection progress over, in this case, I think it was a half a year progress, and this is how we predict the collections will take place until we finally reach all of the completed all of the AOI. So this is how we start. Then we hand this over to either customer support, and then they discuss it with the customer and see if it's feasible. And once we go into the project itself, we set up a collection team, a project team, right? Because we need to monitor what's going on. And what you can see here on those two slides is the one to the charts. The one to the left is the prediction, and the one to the right is how while we monitored the collection progress in red, the actual progress, how we collected. And you can see it closely matches the prediction. And this is what we see in 95% of all cases. So we have gotten so good at the job in the last 20 years that we have developed tools and apply our expertise here, that we can, as I said, in 95% of our cases, we can make a fairly good prediction how a project will run. Even if the weather is bad for a couple of days or weeks, statistically, it will all even out over the course of a larger project. So it's really, really important to monitor the progress, so you can intervene if there's something going wrong, or if you need to address more capacity, and sometimes also keep the customer in the loop, what's going on. The review works like this, after each pass, and then we do this 7 days per week, we check what is usable, what is not usable, and then we erode the area of interest. So we are not over collecting anything, and we're also not missing anything. And that's not so easy as it sounds when you go for larger areas, because you have hundreds, if not thousands of images, which you have to match, and then you have to see what is really usable for the customer. The goal is to optimize the available satellite capacity to a dedicated project, and to ensure, obviously, the successful completion. So I talked about optimizing collections, but how do we actually do this? On this slide, you see two different things. To the right, you see the real-time weather applied in our system, and to the left, you see some optimization process. The real-time weather, and that's what I meant before, allows us to shoot around the clouds to some degree. Every 50 minutes, we get an updated image from a weather satellite, Meteosat, which we overlay with the targets we want to collect. So as you can see, flipping back and forth here, you see the difference between when we started the planning, a couple of hours prior to the satellite contact, to the final plan, which we uplinked 15 minutes prior to the contact. In yellow, you see the areas that we would collect on a given day, and you see how they shift with the moving clouds. Some people would say, why don't you use cloud cover forecast instead of real-time weather? The reason is the forecast is still a forecast. They got better over the last 20 years, but they're still a prediction of the future, and it does not really compare with seeing the real weather as it is at this moment and generating your own forecast, so to speak, in your head, where the clouds are moving and where you actually see where it's cloud free. So that's a very important point, reacting on real-time weather. The second important point is what you see to the left here in green, more or less. Say we have a target which is a square, slightly tilted here, under the starting scenario A. The collection planning system would split this, in this particular case, in 5 scans north-south direction. And it would then suggest to collect 2 on, say, any given pass. That's scenario B. So it would say we collect those 2 strips today and we collect the rest tomorrow or the day after tomorrow. Now the operator comes in and says, I heard from the customer they really need this covered in 1 day. Or the operator could also say, I see that the weather is going to be really bad in the next couple of days, maybe weeks. And today is the last good day, according to the prediction. We need to complete that area. So they can go in, they can delete superfluous scans, they can tilt them, shift them closer to the ground tag of the satellite. They may delete some other targets in the region, maybe north and south, east, west of this area. There might be other images to be collected, but they may have more time. They may have a couple of months collection time. So we may opt to delete them from this plan and dedicate more imaging time to this area. And after we did all these considerations, in this particular case, the operator edited this plan for about 10 minutes, and he more than doubled the collection area and completed the whole AOI in one go. And that's really the difference between the human operator looking into the future and saying, okay, this is what the planning system thinks is best today, but how does it look like tomorrow, the day after tomorrow? What do the customer really need? That makes a huge difference. So these are 2 things which are the center core of our intelligent collection planning, is using real-time weather and optimizing plans of the collection system. But there's also a third way that we can do better than an automatic system. And that's, again, a real life example you see here, a collection over Iceland, by the way. To the left, you would see the AOI being collected, how the automatic software would collect it. It collects an image to the left on day 1, which is in the customer specified cloud cover constraints. It has maybe 10 or 7% cloud cover. And the system would say, okay, this is good enough. It fulfills the specification. Tomorrow on day 2, I'm going to collect only the small remaining corner to the east, which means to the right here in this image. That would be the result if we only leave it to the automatic system. But say on day 2, the collection planner, the operator comes in and sees, well, today on day 2, the weather is actually better than it was yesterday. And if we have a huge overlap between those 2 images, I can eliminate yesterday's clouds, right? So they shift the scan further to the west and kind of over-collect the area. And then again, we have 2 images collected against the same target, but it results in a product that has maybe only 2% cloud cover. So this leads to the surprising fact that you can, on the same 2 days, with using the same sensor, it can result in an image in an area that has 7% cloud cover or 2% cloud cover. That's the difference. And 7% will still fulfill the customer needs. They said 10% is the threshold, but usually a customer is more happy if he gets an image which has only 2% cloud cover. It's very simple. And that's for operators a piece of cake. You see that, and again you have this overview of a certain time series. You see what happened today, what happens tomorrow. They may take this into account for day after tomorrow, and then this usually results in a much better product for the customer. So those are the 3 core tasks that we have: optimizing plans, optimizing smart recollections, and using real-time weather. But there's obviously also a 4th quality factor for images, and that's sun glint. Probably everybody has seen sun glint. It is when surface reflects into the satellite sensor, completely blocking out and oversaturating the sensor. And that leads to blurry streaks or bright patches on the image. And the image to the right is a real life example. If you disregard any sun glint considerations, just shoot into water areas or lake areas, and then that's what you get under certain circumstances. But how can we avoid this? So here are some real screenshots from our planning system. In this example, we are scanning a region in southern Italy. And as the satellite is moving in its orbit, in this case, it's moving from right to left, so does the sun glint reflection area in respect to the satellite also move. So we start scanning outside the sun glint area. Then once the sun glint area reaches the area of interest where we are scanning, we interrupt the scan, usually like for 10 seconds, 15 seconds. And once the sun glint area has moved further from the target, we continue scanning, right? So sun glint can mostly avoid by doing this, looking either from south to north or from east to west. And that works well for relatively flat surfaces like water bodies or flat rooftops. But sometimes you will get occasional sun glint because we have these tilted roofs with glass roofs sometimes, and then they reflect randomly. But it's minute compared to looking straight into a sun glint area where you're guaranteed to get really bad sun glint. So this is how and for the operator, it's really simple. They see that, as you can see here in the screenshot, they see how the sun glint moves in. They stop the scanning until the sun glint has moved away from the area of interest, and then they continue scanning. It's very, very simple and straightforward. So now, since I introduced you into how we do things, I would like to show you how the timelines go. How does it all play out? About 3 days prior to a pass, up to 1 day prior to a pass, we make some very basic decisions, like we select the satellites which fit the collection requirements best, and we distribute the different projects to different sensors. Okay, this GeoEye1 is best for this project, Worldview 3 is best for this project. Maybe a certain project absolutely requires Worldview 3, then it obviously assigned to this project. So we do this basic distribution of resources about 3 days to 1 day in advance. Then 1 day in advance, we can run what we call an analysis pass, where we put everything in the software, in the collection planning software, and have a dry run and see what happens. Do we see anything unexpected? Do we need to reconsider priorities with the customer? Maybe we find some workarounds for any issues that may come up. And we can also have a first look into the weather forecast, so we are prepared what's going to happen the next day and don't get any surprises. Then on the day of the satellite contact and the imaging itself, starting 3 hours out, up to 15 minutes before the contact, we start optimizing the plan as I showed you before. We start fiddling with the scan directions, we shift scans, we delete orders, temporarily suspend them to say, we rearrange priorities. We might be able to combine certain orders. Customers may have interest in regions nearby, so we may be able to combine it with one scan, which we call bonusing. Then we use that real-time weather, as I showed you before. We may want to call the customer even, or customer support, and just make sure that we understand the priorities properly. And that doesn't happen very often, but if it happens, it's really necessary, and customers are usually very happy that you call and say, okay, actually we can collect something today for you, which we did not expect. Should we go for it? And they say, yes, okay, do it, or no, I need a field study, I need to be on site, postpone it for the next opportunity. So things like this happen. And crucially also, as I mentioned before, we also look into future collection opportunities. You can say we can optimize today's pass, but also looking in the next future opportunities. And this is, again, a difference between an automatic system, which tries to optimize each and every pass for each single day, versus a human that can look into the future and contact the customer and say, okay, if we don't do this today, how about tomorrow? Then we can collect something else today. And that's virtually impossible with current software. Theoretically, it can be done, but then we're really talking sophisticated AI. So all these words here, these long words can be put in a small slide here. you see how customer support and the customer communicate with the collection manager, and then collection manager communicates with the collection planner, and the collection planner is actually generating the imaging plan and sends it to the satellite. 15 minutes prior to the contact, the plan is done, and the actual sending is done when the satellite comes over the horizon in the first 15 seconds. The satellite will receive the plan. And as I mentioned several times, the collection planner is looking at the real-time weather, and the collection manager is looking at forecasts and trying to integrate several plans for the future also. So to conclude, in 20 years of tasking satellites with a local ground station here out of Munich, we consistently see a much higher success rate for single orders as well as for large projects when we apply this expertise and the flexibility compared to systems that use only this automatic centralized planning tool, which also works, but just gives you a lot less. And some projects might not be possible with automatic planning. So I hope I didn't overload you with information here and it all made sense for you. And for the time being, thank you very much. And I will now hand it over to Daniela. Thank you. So how do I stop sharing?
Okay, George. I think, Daniela, you can start to share.
Okay.
Okay. Good day, everyone. I share my presentation. While sharing, I introduce myself again. I'm Daniela Valentino from Planetek Italia. I'm a product specialist in the market of satellite data. I've been working in Planetek since about 15 years. And my main roles in the company are managing opportunities coming from public administration and defense customers, keeping contact with data providers, and handling distribution contracts. Okay, my presentation is on. Perfect. Planetek is a group of companies. The main company is Planetek Italia, located in Bari, where I live. Planetek Hellas is the sister company located in Athens, and the group also includes two spin-offs of the university. GEOSeries is a spin-off of the University of Tor Vergata in Rome, and GAP is a spin-off of Polytechnic of Bari. We operate in three strategic business units, which are market-oriented. Space Stream replies to spatial agencies and system integrators developing spatial systems. Government and Security Business Unit, that is the business unit where I work, operates with Italian and international public administrations and defense customers and European institutions, agencies, and B2B, business to business, work in the private market, and in particular with engineering and oil and gas customers. Today, I'm going to present a case study on how the municipality of Cernusco sul Naviglio, placed in the heart of Lombardy region in Italy, is using high-resolution satellite data to transform its urban planning processes. Cernusco sul Naviglio is a nice town strategically situated in the northern part of Italy. It is just 16 kilometers east of Milan. That is one of the country's most prominent economic and cultural hubs. Its location in the Milan metropolitan area makes it an integral part of the regional landscape. Indeed, it is a key player in the urban development of the region. Like many many municipalities across Italy, Cernusco recognized the critical importance of having accurate and up-to-date cartographic information. This data, in fact, represents the basis for urban planning, land management, and various administrative processes. Their website includes a complete source of information they manage and update. As you can see, the cadastre database, topographic database, geological cards, and so on. For this reason, the municipality of Cernusco sul Naviglio embarked on a mission to enhance its cartographic resources. They acquired high-resolution data with the impressive 15 centimeter resolution collected in January 2023. This level of detail allows for precise mapping of the town's terrain, infrastructure, and property boundaries. As we can see in this picture, it's like having a magnifying glass for urban planning. This is just a case of an area under construction. But now let's investigate the specific application of this high-resolution satellite data. The primary objective is to streamline the activation of online tools for digital construction processes, specifically in the area of edilizia digitale, that is the digital construction. A key feature on the website of many Italian municipalities is the Sportello Unico per l'Edilizia, referred to the single desk for building. It is an online resource playing an important role in simplifying the procedures related to construction and building activities within a municipality. It represents a centralized platform provided by municipal authorities to manage all matters concerning construction and building permits. It includes several tools. It is a centralized information. In fact, it contains construction-related inquiries, permit applications, regulations, guidelines. Another tool is the status tracking. In fact, applicants can track the status of their permit applications in real time. It is also a communication hub. It facilitates communication between applicants and municipal authorities. In some cases also, many Sportello Unico platform offer online payments option for permit fees. In conclusion, the municipality of Cernusco sul Naviglio's investment in high-resolution satellite data showcases their commitment in modernizing urban planning and administrative processes. This initiative not only benefits the town's residents and businesses, but we hope that also sets an example for municipalities across Italy and maybe Europe. Thank you for your attention. I'm available for further questions or discussions on this topic. Thank you.
Yeah, thanks, Daniela. It was super interesting. And now we go to the, I will start sharing back again. So again, it was very interesting, and it's very nice to see also that the municipality it's using very high resolution data. So I think the presentation is fine. for this type of projects. There is a lot of use cases in the community, in particular for the 15 centimeter HD for object detection, in particular for military and defense. But we see also an increased demand directly for this type of use cases that Daniela was showcasing for real estate, urban planning, and so on. So now to wrap up also on the topics that we've been discussing through the webinar, again, I mentioned at the beginning, there are a lot of technical topics. It took some time to find a way to merge all together and to present this in an easy way. So right now, I will present few one-on-one comparison, where of course, leading also to the end of the webinar, the Q&A. Here you can see, for example, like for the satellite collection, we will have resolution in general from 30 to 40 centimeter GSD native, meaning that it's the native imagery collected from the satellite, 15 centimeter HD. So it's resulting as the processing that they've been sharing. And you saw also the very high quality that Daniela has been presenting, which is also confirmed directly from the authority as a very good quality, also for urban mapping and any sort of LiDAR or GIS that can be used for feature extraction and so on. So when we look at the aerial platform as well, like on a one-on-one comparison, of course, the clarity and the level of detail, the GSD that you can collect from an aerial with an aerial camera sensor can go down to 1 centimeter, for example, or 5-10 centimeter, which of course is still not possible with satellite sensor. And when we look also at the accuracy, we will be in the range of around, and I saw also some questions. Thanks a lot for making this session dynamic. And I hope you will stay also for the Q&A, which is making it even more interesting. Some of you were asking about the accuracy, and this is the slide that we prepare for it. So on the satellite, we are around 5 meter CA90 without using ground control points. By using ground control points, we can get down to sub-meter accuracy. Of course, when we look at the aerial solution, then we are a few pixels away, so without using ground control points, meaning that you have some relative accuracy in general between 1 to 3 times the GSD. So of course, in terms of accuracy on the aerial platform, you can get much better clear detail down to 1 centimeter or with the UV system, and then also the resolution and geometric accuracy. It's what I've been sharing. Few parts that maybe we'll get the presentation a little bit more into the topics of the multispectral bands and the homogeneous datasets. Here you will see some example just following up with the 8th multispectral band and how these bands can be used. Just before getting back to the slides, I saw one question if the multispectral band can be used for analysis of vegetation, and this is actually one of the use cases, but there are many others. Another point which I believe is also very important is data homogeneity, so homogeneous data sets. As George was showing before, with two access with true imagery collected over the same pass or over 2 days. We use always the same sensor or a combination of sensors that are matching very well together. So less than 1 minute collection for whole cities means that you have very consistency across the data sets. At the same time, if we look at a country like Germany, where the complexity for aerial survey is increasing, you have to have a number of aircraft, might be a different type of aircraft, different type of sensor, then this could lead to different type of imagery, which have to be assessed and processed in post-processing. So all the inconsistency into the radiometric adjustment, the balance and color balancing, this is done usually in the processing and production. So something that can be done within 1 day, for example, for the dataset that are collected with satellite. Here you have a nice one-on-one comparison of a 15 centimeter image, so native 30 centimeter on your left, and I put here the satellite also as a reference. And here you have a native imagery from aircraft, so 15 centimeter open data. It's nice to see that in the 15 centimeter HD, you have a very good understanding of the streets, land, like you can also do some classification. Of course, there are some small artifacts around objects, but it's giving a very good clarity and understanding of what the site that you're looking at. At the same time, when you look at the native 15 centimeter imagery, so without HD processing, this is native, so you have much more clarity into the details. And again, we were going back to the topic of the geometric accuracy. This is also leading to better geometric accuracy that was reported in the table before. Now to have a few points leading also to the question that you've been asking about the multispectral band. With WorldView 3, we can collect up to 16 spectral bands. And here I wanted to put together some use cases, like how these multispectral bands are actually helping our clients in their daily projects. So here you have a 4-band imagery, 30 centimeter resolution. You can see that you can already identify some hailstorm damage, production loss, and then you can get to the question, are these the same crops? It's much easier to see actually in 8 bands, because you have a better penetration of the vegetation, which is coming from the additional band, and can solve some of this analysis. So it's possible also to do 3 species classification. And here, comparing, for example, RGB, what is usually taken, for example, for an aerial sensor is RGB plus near infrared. So you have the use case in front of you. In this case, we can go up to 8 bands. So this is a WorldView 3 image. You have the RGB, then we add the 4 bands with the near infrared, and you start to see some like you see a little bit better into the vegetation. But of course, when you add the additional 4 bands into the 8-band imagery, you can clearly see that this is maybe a different type of species, so different type of trees, and it's supporting the analyst also for this type of classification. This is working well also in urban areas. So you can see here you have a 4-band image with near infrared and your 8-band image. Then some features that are not really clear into the near infrared image are becoming more clear when you add additional bands. So this is providing better clarity, adding an additional level of details that are usually not possible to be seen in the traditional natural color image. This is another example of smoke. So this is natural color. This is 4-band and near infrared, and you can see that when you add additional 4 bands, you can they are penetrating a little bit better through the atmosphere or to the smoke, and you can see a little bit better what you have actually in the area. We are getting now to the Q&A. So just a few unfortunate topic like about geographical restriction, for example, which are adding an additional complexity level for the aerial surveying planning, for example. So this image is coming from Flight Radar from 24th of February. Unfortunately, when the escalation of the conflict in Ukraine got much the invasion basically started on that day. As you can see, the complete aerospace of Ukraine is empty. There are no commercial flights, and this restriction are not just applying over Ukraine, but are applying also around the borders of Ukraine. So Aerocontrol is and of course, this is something that has to be taken into consideration in case there is the need of collecting imagery over this area. We've been collecting imagery up to the minute over this area, and this is just an example from a few weeks ago of the grain port in Ukraine with GeoEye 40 centimeter. So to wrap up, and really this is the last slide before moving into the Q&A. So we have been discussing about satellite platforms, so very well suited for large-scale collection. You have unrestricted access, so we can collect without planning, for example, for a flight permit, or if you think about a project, for example, where you have to do obstacle mapping into an airport, like Heathrow Airport that I was showing before, we can collect 30 centimeter imagery, deliver within the same day 15 centimeter HD, and this is supporting some classification, like any type of mapping of object. It's a little bit more critical from the aerial point of view, flying restricted areas or flying strategic infrastructure like an airport. You have to fly much higher. And this is coming also with some logistics. So you have to do the planning, you have to prepare also for the permit and to get the clearance. This is coming a little bit more quicker for the satellites since we can collect on the day that we have the access. At the same time, aerial platforms are providing very higher clarity with GSD going down to 1 centimeter or 5 centimeter, a better geometric accuracy, as you have seen from the table. The beginning of this idea and project for this webinar was also to come together, and what we've been answering already in your question, it's really insightful, is the fact that many of you, I think 44%, are using already aerial and satellites. So this platform are coming together to offer the best possible outcome. So there are different projects, and maybe this is opening up also the Q&A that we can discuss. The idea, for example, to have persistent monitoring of specific EOI. With the worldview constellation, we have a revisit time up to 2 or 4 times per day of a specific AOI. When the Legion satellites will be commercially available, we will increase this revisit time up to 9 to 14 times per day. So this type of persistent monitoring, persistent focus, of course, is not possible with an aerial platform. But for example, as Daniela was showing, there are already city council using 15 centimeter data as a base layer for their mapping or online portals. So both products are coming together, and there is also the possibility, for example, to come to use an orthomosaic from the aerial survey from the year before, and then overlying 8 bands imagery, for example, for analysis on the vegetation or inspection of specific materials. So that's, I think, it's the whole ideas, and I think I would be very happy also to go through the Q&A, since we are getting close to the 1 hour timeline that we have set. So I saw a few questions, and I also saw a poll. I don't know if we get like all back online, also you, George and Daniela. I will take a quick look at the polls, which is truly interesting. But Matthew, did you receive any questions that maybe we can start off, or we start with the poll and then we will start to check some of the questions?
Yeah, we do have some questions. So let's start to go over those, and we can also look at the poll and discuss that as well. George, do we have you online right now?
Give me a second, please.
Okay, sure. So what I'll do is I'll start with this question. I believe it's directed towards Daniela. So for the city that you presented about near Milan, can you say why the user chose satellite imagery instead of aerial data? I would expect that the aerial data would have been available for this city. So could you give a little insight on why this decision?
Yes, in Italy, public administrations can receive aerial data every 3 years, and only at 30 centimeter of resolution. So it's very complicated for a city or a province to contact a company for flying or to tender new aerial collections, but also to find the budget for this instead of purchasing a single satellite image.
Okay, yeah, that makes sense. I think actually there's quite a few states in the EU that are doing aerial collections at regular intervals, but not yearly, and so that can, I suppose, present some problems if you need yearly refresh rates on your data. So I have a question here for George. So we tend to hear oftentimes at conferences and events and webinars how automation is sort of our solution to everything these days. But much like your presentation, we also oftentimes hear that human intervention is still needed in these workflows. So do you have any way to actually quantify how your team's intervention aids the automated scheduling?
Right, it's a good question, of course. Yeah, first of all, automation is absolutely necessary as we move into using more and more satellite constellations. You cannot do everything manually. So there's a huge amount of automation that you do need for sure. And also in areas which don't have high population density, say deserts and stuff like this, that's all fine. Once you move into regions like Europe with a high population density and high order density and complicated weather patterns, those automatic systems are kind of overwhelmed by the complexity of the situation. So to give it a number, I mean, over the past 20 years, we started out with Iconos, QuickBird, and WorldView 1, 2, 3, 4, GeoEye. So we have quite some experience with very different sensors. And I always find that we at least do 20% better, at least. In most cases, 50% and more, even 100%. So sometimes we double the collection capacity or cut the collection time in half. That has been consistently proven. It depends a little bit on the project. And some projects even become only feasible when we use this intelligent collection planning. And they would be infeasible with automatic collections only. So it's a yes and no. Automation is super necessary for many purposes, but it has its limits, and I think the limits are when things are getting really, really complex. It may change in 10 or 20 years, AI is coming in, I don't know. But as it is today, for complicated and complex situations, we do need it, and we get anything between 20 and 100% more out of the system.
Yeah, I think that's quite interesting. I would have expected somewhere in the single digits range of increase in efficiency. So actually 20%
at least.
Really impressive to hear. So Valerio, so yeah, if we could touch on the poll here for a moment. So yeah, we asked, what are your biggest challenges in dealing with remote sensing data? And while there is one answer that has inched ahead, balancing data quality with cost. Actually, it seems like all of these challenges are pretty important. So do you have any insights into these responses? Any comments on them?
Yeah, it's very insightful, Matthew. Like, thanks also for going on with the polls. I think that's making this very interactive. And I think it's merging well with the feedback that we receive also from the online surveying that we started before the webinar. Definitely what you mentioned, frequency of the imagery and collection, that is also very interesting. So balancing data quality and cost, of course, is very challenging, in particular for let's say what Daniela was mentioning, planning the collection and the aerial flights for a consul or like Cernusco sul Naviglio implies opening of a tender, implies a budget which is allocated, and anyway the authority is issuing this every 3 years, as I understand in Italy. In Germany the timeline is a little bit different, but I think that is one of the major parts that is driving also the choice to what is already available. For example, a tasking capability that we can fulfill, like in the project with Daniela, or even archive imagery. So definitely balancing quality and cost. High quality, what I was sharing about 1 centimeter, 5 centimeter aerial imagery. Of course, they have better visual clarity and better geometry, like in terms of accuracy, but they're coming with a cost. Considering also fuel costs that are changing very quickly, this is getting more dynamic into the planning of this type of operation. While for us, it's much easier for this type of resolution, 15 centimeter HD, for example, just what Daniela said, I think was the perfect wording, just purchasing an image. It's coming as a very quick decision transaction. The price is fixed, so it's matching the budget much easier. Other topics that I see in the pool, which is also interesting, is the different collection opportunities like weather, geography, restriction, etc. I think that is what I was sharing. So unfortunately, I've been using the example of Ukraine, which everyone is hoping that it's going to end at some point. but it's like a restriction can also be, for example, having an area of interest which is very far from an airport. So you have additional logistics to plan, because from the time that you fly to your IOI, you have maybe 1 hour span or 2 hour span. So this is, of course, from aerial collection, weather, geography, restriction, and clearance as well, are a little bit more challenging, while with the satellite, we can, as George mentioned, we start with the feasibility, we proceed directly, and around 1 day or even less, like a few hours, you're already a response and maybe even an image. The other point I see, data processing and storage resources. We hope that the table was, so first of all, the slides will be shared, and this topics is something that I think was quite interesting to present to you today. And I'm happy that there was also some of questions coming from the comparison of the data sets. I think it will be more clear, and we'll be very happy also, to have additional conversation outside the webinar to evaluate and also better define the next sessions. Frequency of the imagery collection. I mentioned like that we have a very high revisit time with the worldview constellation is around 2 times per day, up to 4. Once the Legion satellites will be operational, we will go up to 8 to even 15. So for persistent monitoring, or the site that, for example, Daniela was showing, where you have construction, this type of high revisit per day, it's of course something very unique that cannot be offered for from an aerial collection, for example. So I think is the pool. I see that questions are still coming in while we're talking. So I don't know, Matthew, how would you? There was any other question that you saw?
Yeah. Let's pick a couple of these out of the chat here. So we have one here. Actually, it's a bit more related specifically to a product from Planetek. So it's addressed to you, Daniela. To what extent can you extract building footprints in urban core areas? So if you could speak a little bit about the quality of the building footprints product.
Very, very good question. Yes, usually municipalities, provinces has very old cadastral maps in their archives. Okay, they for sure provide a very good and official source of building footprint data. But with the satellite data, with this accurate resolution, the activity of updating those resources is really facilitated and also improved, because much more details of buildings can be detected, also of few centimeters. So it's a very good way to update old maps. Yeah.
Great. Let's see. I saw another good question in here for George. Let's hope I didn't click out of it here. Yeah. So I think this is something George can answer. So in large scale data collection, how do you manage temporal lags between the small units? And I believe they clarified the question a little more. George, if you read their clarification as well.
Not yet. I didn't see it.
Let's see. So let me find it here. Yeah, I believe, trying to find the exact question here. Here we go. So clarification, yeah, when scheduling the data collection, you may get days or weeks in between the collection of small units. What is the maximum delay that you can consider in a single collection?
Okay, again, a very good question. And the answer is it depends on the customer, right? Some customers say things have to be collected on 1 day. That's a requirement. And that would be part of a feasibility. Can it be collected on 1 day, right? Or customers say, we're happy if it's done over the course of 6 months and we take care about any differences in vegetation or whatever. So it really depends on the customer. It's not our decision to say we consider this one collection. It's based on the customer requirements, really. And it can be anything between, it has to be in one day if a customer needs that, or if it's a larger area, or the customer is happy if half of the image is collected today and the next is collected next year. Some don't care. However, all that said, we always try to collect the images as close as possible in time. Right? That's one of the things that the operators put in mind. They say, okay, we collected half of this yesterday, let's complete it today and not postpone it for another week or so, just to keep it together. That's one of the, but this is like an extra service to make it easier for the customer. But again, it's the customer who decides what they would accept as a temporal lag between different images.
Okay, great. Great response. Let me just scan a couple of these questions quickly. I think some of them might be a little more appropriate for us to, for some of the people on the team here to respond with a written response. Some of them aren't totally in the scope of the webinar here, although still some good questions. I think, no, I think really that's, yeah, I think really we've answered most of the questions that are more open-ended and appropriate for the webinar here. The ones that still remain, we will certainly respond here in the next few minutes with a written response. But I think it's some of them are have very specific answers that can really just be specifically addressed. So. Yeah, so if there's nothing else from the speakers, anything else that you would like to touch on, I want to thank you all for joining us. Everyone also that participated, registered, and watched the webinar. Also, thank you for asking so many really nice questions. I'll keep the chat and the Q&A open for a few minutes while some of us respond. Of course, our speakers will go ahead and exit. Yeah, if you have any further questions in the future, you can please contact EUSI or Planetek personally. I think we can really respond to most any inquiries that you have, even if it is related to aerial imagery. While EUSI doesn't directly provide aerial imagery, many of our partners do, and we like to be honest and open about which projects fit satellite and aerial or a combined approach. So we're happy to refer you in the right direction. So thank you, Daniela, Valerio, and George.
Thank you.
Thank you, Matthew. Thank you, everyone.
Thank you.
Thank you, everyone.
Yeah.
Ciao.
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 Bye-bye.